Okay, so now we're recording, and let's take a look at this first question here. This one went okay. All you had to do was just do 18 squared plus x squared equals 20 squared. If you use a calculator, that's 324, and that's 400. X squared is 76. And you isolate x squared, x is root 76. I said no decimals, and it's simplified the radical. So 76 can be broken down like this, 2 and 38, and 2 and 19. So it's the same thing as saying root 4 times 19, because 2 times 2, of course, is 4. And root 4 is 2, so you get 2 root 19 as the final answer, 2 root 19. So if that doesn't seem too bad, it seems pretty fair, right? That's number one. Okay. Number two, you have to use the 30-60-90 ratios. Now, if I pull up the reference sheet, it's right here. So don't worry about the variables. Just know how the sides are related to each other, right? The side opposite 30 degrees is a small side because y is definitely less than 2y and definitely less than y root 3. The hypotenuse is 2y, so the hypotenuse is double the shorter leg. So see how this right here is double this guy, right? So hypotenuse is double the shorter leg, and the longer leg is root 3 times the shorter leg. So all you have to do is just apply it. That's all you gotta do. So in this case, that's the shorter leg, right? That's the shorter leg. That is 30 degrees. So that makes that 10. Because the hypotenuse is double the shorter leg, and it makes that 5 root 3. That's it. There's no reason to stare at it for 10 minutes. Move on. So that's all you gotta do. We'll keep moving. Same thing here, 45, 45, 9. It's in the reference sheet. It's right here. So all you gotta do, let me move this all the way to the left here. Yeah, just look at the reference sheet. The two legs are both x and x, which they should be because they're opposite congruent angles. 45, 45 are opposite of them. The hypotenuse is x root 2. It makes sense when you do Pythagorean Theorem that if you just square this and square this and square this, x squared plus x squared will equal 2x squared, right? So yeah, so all you gotta do here is just realize that, well, if that's 8, that's 8. And that's 8 root 2 because the hypotenuse is root 2 times any of the legs. That's it. That's all you gotta do. 4 is a little tricky. It's one of the harder concepts, I feel, of geometry. But if you were to draw some triangle, redraw these two triangles. So that's going to be this one right here that I just traced in red. And this one I'm going to trace in blue. I'm going to reorient it like this, where I rotate it 90 degrees counterclockwise, and that's x. Okay. So these are similar triangles. The reason why they're similar, if you were to hypothetically make up an angle for this guy, like say 20, then this would be 70, of course. And since that's a right angle, that's also 20, and that's 70. So we're going to have similar triangles, and I already have them in the right orientation. So 3 over x equals x over 14. Cross multiply, work it out, you get root 42. And then you could round, which is I think 6.5, sorry. That rounds to 6.5. Okay, let me let Isaac back in here. Here we go. And stop me if you have questions or type in the chat if you're confused by anything. 5 and 6 kind of tells me that you guys still need more work with trig. You guys are still getting stuck with it. SOHCAHTOA. Okay, SOHCAHTOA. So here's your angle. That's clearly opposite. That's clearly hypotenuse. We clearly use sine. Sine 24 degrees equals x over 33. X is the opposite. 33 is hypotenuse. Multiply both sides by 33. Punch in the calculator. Done. Takes like less than a minute. That will be 13.4. Okay. So that's all I got to do for that one. And I will share this recording with you guys, and test corrections for this will be due next Friday. Obviously, I need to hand back the test to you. For me to scan all these would take a while. So maybe you can work on the midterm corrections. If you didn't get your midterm back, I could scan those and email them to you later today. So you could do at least those corrections. And the midterm test corrections are due next Friday as well, on the 22nd. And we are in person Tuesday, so I can give you back everything on Tuesday. But for those who were not in class yesterday, when I did pass back midterms, at least I could scan those and hand back and then email them to you. Okay, number 6. This is a problem where you have to make some connections. We did talk about area. This is an old topic. Just because we covered it in the previous one doesn't mean you can forget it. You got to remember everything. Area equals 1/2. And if you have a hard time remembering everything, just look back at your old tests, look back at your notes. Area equals 1/2 times base times height, right? And it's open up, by the way, right? You could, and I let you guys use online resources. So you could totally just search that. It's not that hard. 1/2 times base times height. It's right there. If you type it in Google. And then that's the base, that's the height. If you have a more traditional triangle that's not right, then that would be your height. And it's perpendicular, but the leg is automatically perpendicular to your base. So it serves as both a leg or a side of the triangle and a height at the same time. It has a dual kind of purpose there, or dual utility, whatever word you want to use. So that's the height. In order to solve for the height, you got to use trig. Tangent 48 degrees will equal h over 50. So you had to make that connection. Realize, oh yeah, I used trig to get that height. Okay, now you're golden. 50 times tan 48 degrees. H will be, I think, let me look for my solution key here. And I do have the solution key all worked out, so I could scan that also and put it up. The school G, so the height's going to be 55.5. So then your area is going to be 1/2 times your base times your height. And you should get 1388.3 meters squared. And then the perimeter, now you know the height for one of the legs, which is 55.5, and that's 50. You can use Pythagorean Theorem, right? That's an extension of what we've been doing in this class already. Solve for C. If you solve for C correctly, you should get 74.7. And add up all the sides. So this is 55.5. This is 74.7. Add them up. Add them up, you get 180.2. So you guys put 180.2, but didn't show any work. They're not only going to be a point. So you guys show me some work, right? And I did say show your work. I was very clear about that. So that's number 6. Questions on that one? All right, let's keep moving. Number 7. Some of you guys did okay. Some of you guys struggle with this one. So you got to draw a diagram. And I'm not going to always give you diagrams. You got to know how to draw them. So here's home, here's school, here's library. Boom, took like a few seconds. 6, 14, 18, because you're told that. Done, another few seconds. Doesn't take very long. Okay, fantastic. Now, again, you have 6, 14, and 18, okay. You're asked to determine if your friend is correct, if it's acute. Remember, we talked about this. It's in the reference sheets. It's right here. To compare C squared to A squared and B squared. C is the longest side, A and B are the 2 shorter sides, right? So your 2 shorter sides are 6 and 14, obviously. 18 is the bigger side, and you're just comparing these two. That's it. You should get 36 plus 196, and that's 324. Use a calculator. It's pretty clear the left side is going to be smaller because you get 232, which is less than 324. When that happens, when C squared is bigger, when C squared is bigger than A squared plus B squared, use your reference sheets right there. It says right there, it's obtuse. C squared is bigger than A squared plus B squared, it's obtuse. That's it. Not that hard. So yeah, that's what we do for that one. We have done problems. We've done problems like this, may not design exactly this way, but you can draw the triangle and just apply it. That's all. So it's a lot of it's just applied math. 8. More of the same thing, just using some trig. You have to solve for angle A. Well, that's opposite. That's adjacent to angle A. Tangent is what we're going to use. Tangent of angle A. Because remember, SOHCAHTOA. So you got to use the tan part, right? Tangent of angle A is 18/12. Angle A is the inverse tan of 18/12. And then just use your calculator. You should get 56.3 degrees. Okay. 56.3 degrees. So that's more trig. Then we get to some multiple choice problems. These are chapter 8 questions. Now this one actually, I think all the answers are wrong. Definitely, it's a rhombus at the very least, because all the sides are the same. At the very least, we know that. And rhombuses are parallelograms. And of course, this has 4 sides, so of course it's a quadrilateral. And that's really all we could really say, right? Because I don't know what's going on with these angles here. I have no idea. So I can't really say, I mean, could it be a rectangle square? It could be, I don't know, because I don't know anything about these angles here. And so we look at the reference sheet. Yeah, obviously, yeah, you do have 2 pairs of opposite sides that are congruent, so that's good. You do have all 4 sides are the same, that's good. And it's 4 sides, but I can't really say much more than that. The problem is that none of the choices show that. They don't have rhombus, parallelogram, quadrilateral, and that's it. They don't have it exactly like that. I mean, C's pretty close, but that should have been parallelogram. A has rhombus, parallelogram, quadrilateral, but I really don't know about this. And then of course, B makes no sense, nor is D. So I gave you credit for either A or C. If you said A or C, I gave you full credit for it. So Abby, was that your question?
Yeah, my question was if you were just gonna like take the whole question out of the test.
No,
or
I gave, if you said, as long as you picked rhombus, I gave you full credit. If you did say D, I did take out 2 points because, but if it does make a difference at the end, like, okay, like those 2 points could bump you up for B plus A minus, I'll give those 2 points. I'll you know, I mean, obviously I'll help you guys out, but you know, if you didn't have A or C, you did lose 2 points because you do need to at least say it's a rhombus. For 10, okay, again, you're told this is a rhombus, right? And use a reference sheet. They said diagonals are perpendicular, so you got to make that connection. They're perpendicular, that means you got right angles. If you got a right angle, it means 90 degrees. So all these are 90 degrees. So you set each of these equal to 90 and solve for the variables. That's it. Here's Z is going to be 3. Obviously, those 2 work, those don't. Here, X is 5. So now we know it's C. And then this one, just for grins and giggles, if you're curious, like, okay, what's going on with this one? You don't need, now you know the answer C, but if you want to solve for Y, go ahead. 5 plus Y, Y is 85. So let's see. Rectangle. Diagonals are the same. You're told that in the reference sheet. Diagonals are congruent. You're told it's a rectangle. So, and you're given the variable expressions for each diagonal. KM's a diagonal, LN's a diagonal. Semi-equal. Actually, I think this one's fine. I think almost everyone got, I think everyone got this one right. I don't think this is an issue. So 6x equals 33, you should get 5.5, so that's easy. Here you want to force this to be a rhombus. You are told that rhombuses they bisect, the diagonals bisect the angles. So that means that these angles are the same. So then 15 equals 3x when you move the terms around. X is 5, so there you go, you should get B. 13, you want to force this to be a rectangle, and you're told that AE and BE are the same. Well, the diagonals get bisected. In fact, diagonals are congruent anyway. So I probably could just do 1 markings on each of these. So these are going to be equal as well. If you do that correctly, you should get 28 equals 2x. X is 14. You should get B again. Yeah, this page went fine for everybody, I believe. So that's good. 14, remember this is not an isosceles trapezoid, so you guys thought it was. You can't go based off looks, even though it kind of looks like it, but can't go based off looks. So somebody said A was 113 and that B was 36. That wouldn't make any sense because this wouldn't then add up to 360 because it is a quadrilateral. So it doesn't make any sense to say that. What you do need to realize that these are parallel. These are going to add up to 180. And these will also add up to 180. So A is going to be 144 and B is going to be 67. So that's why you get A as an apple, 144 and 67. That's it. And again, you're told that also right here, one pair of parallel sides. Also, you're told that that's just for isosceles, I guess, but still, you should be able to make that connection because we learned about parallel sides in the previous unit, that same side to your angles add to 180. For 15, now you have an isosceles trapezoid, you have angle J and M. Those are your base angles. They have to equal each other. Here's J, K, L, M. J is 20x plus 9. M is 14x plus 15. Okay. To them equal. 6x equals 6, x equals 1. So somebody got circle B, but then problem didn't ask for x, asked for k. So now you got to solve for this guy. Well, this is going to be 29 when you put 1 for x. This will be 151 because they have to add up to 180. So you get A. $16 for the most part was fine. It's pretty straightforward. We learned about this recently. This is the mid-segment, the average of these two sides. 46, 125, add them up, divide by 2, and you get your answer. You get 171 over 2, you get 85.5. So you get P. Now the home stretch here, these went fine, I felt. Didn't really notice this being an issue. Angle S is 80. So that's also 80. And again, if you go to the reference sheet, the kite says one pair of opposite angles are congruent. So those are the opposite angles that are congruent. Angle R is 130. So if you add it all up, you should get 290. So that's 70. So it's B. X plus 5 will be that side. So these are the same. The markings tell you that. And also for a kite, you're told that you have two pairs of consecutive sides that are congruent. 2x plus 5 and x plus 12 are congruent. X equals 7. Nice. So B and D are out. That's 12. That means this has to equal 12. That means Y is 16. So either A or C still work, but then when you plug in those values, you get 19, 19 for this side, and you get 12, 12. So that's why it's going to be C's and cats. Okay. So that covers the entire unit test. I'll show this recording later today. I also have my solutions. I'll scan those and put them up in Schoology. Obviously, if you go to Schoology, recordings is where we're in semester 2 now. Recordings from class right there. That's where I put the recordings. The solution keys, I'll probably put them under actual exams, and I'll just put it right there. I'll call it Unit 4 solutions. So, okay. Hopefully that makes some sense. And you can do corrections for this. I won't hand these back up, obviously, until we're in person on Tuesday. But you can do corrections for them. And I did put the grades in Schoology. Let me pause the recording. Let me just make sure they're in PowerSchool and stop sharing. Okay, so this section is called Use Properties of Tangents. Before I get into that, let's just do a quick warm-up. So it says draw and label the center. It's pretty obvious. There's a center. Draw a radius. That's a radius. And a diameter would just be a segment that connects two points in a circle but goes through the center, right? That'd be a diameter right there. Of course, the diameter is always twice the radius, right? If you double the radius, that is the diameter. So that's just very basic stuff about circles. And a circle in general, some people don't quite realize this, but a circle in general is a set of points equidistant at fixed points. And the fixed point is what we call the center. And the distance from the fixed point or the center to any point on the circle is called the radius, right? And the radius is a consistent value for any particular circle. Yeah, let's just skip that part. That's just a vocab thing. We don't worry about that. In case you're curious, I believe it's reliable, trustworthy. Resolute means you're determined. Tenacity also means determined. Relevant means if it's something that you should care about or is important. Insolent, I think, means insulting. Anyway, don't worry about it. We'll just keep moving. Okay, some terminology. Chord, secant, and tangent. These are terms that you definitely will need to know if you do want to take in calculus in a couple of years from now. Obviously, most of you are doing Algebra 2 this fall, and then most likely pre-calculus the year after. And if you do calculus the year after that, you do want to using these two terms a lot, a secant and a tangent. A chord, first of all, is just simply a segment. So it's not a line, it's a segment, has two endpoints, and it just connects two endpoints of a circle. So a diameter could be a chord. That could be, it is. Diameter is a chord. In fact, it's the longest chord of a circle. It's the longest chord of a circle. A tangent is a line that touches the circle in exactly one point. So it touches in exactly one point. That's called a tangent. A secant crosses a circle twice, here and here. And it's a line, not a segment. Chord is a segment, secant's a line. And tangent is also a line, but it touches just one point of the circle. Now, one thing that is important to know, which I will need to discuss, well, actually I'll discuss the next page, but I'll just tell you right now. When you do have a line that, so let's draw a circle, and it's actually I could do something like that, right? And if I draw a line that touches in exactly one point, and if I put a center, there's a center. And if I draw another segment between the orange dot and the red line, and I make it a radius, right? Because if I drew another radius, say like this one, obviously it's not touching the red line. So I want the radius touching the red line. Then guaranteed, these will be perpendicular. Guaranteed these will be perpendicular. So a tangent line, and we'll talk about this on the next page. A tangent line is always perpendicular to the radius. That's gonna be the key concept for this particular section. And you know, this is stuff that usually spend a day or two covering in a typical math class. And then 10-2 and 10-3 also a day or two. So we're doing all this in one day. So we're covering a whole week of stuff. But that's pretty tough stuff too. So that's why I'm assigning some homework this weekend. Usually I think some of the weekends I've not assigned homework. I think I need to because this is really tough stuff. But that's not that hard. I'm just telling you right now, that's what it is. You form a right angle between the radius and the tangent line. And we'll talk about that on the next page. But for now, we'll just worry about labels of whether you got a radius, a chord, a diameter, a secant, or a tangent. So it's 5 labels here. So let's take a look at AC. That's totally a radius, right? Radius connects the center to a point in the circle. And it should say a segment. That connects center to point in the circle. A chord is also a segment. That connects 2 points on a circle. So right here, E, that's totally a segment, and it's connecting 2 points in a circle. So that's going to be a chord. Now, if you had little arrows, then it would have been a secant. But we don't have those little arrows there. CB just knows another radius that connects the segment that connects the center to a point in a circle. So CB is another radius. AB is a diameter. AB is a diameter. That's because the diameter, same thing, is a chord. That passes through the center. This chord passes through the center. So it's a little bit special. And then a secant tangent lines. Remember, that's a line. That passes through 2 points on a circle. So AG is definitely a line. If we have, or AE is a line. So that's definitely a secant. And then finally, a tangent. That's another line. So it kind of just grazes the circle, just touches the circle once. So DE is going to be a tangent. Sometimes as a figure of speech, to say if you're going off on a tangent, like if all of a sudden I started talking about the Giants lost last night, which I was grading when I was watching the game last night. And also in a fantasy, I was playing some guy who had Corbin Burns, and I don't know why they kept him in the 7th inning, got in a strikeout, and I lost by a few points. I'm really upset about that. But anyway, see, that's going off on a tangent. So sometimes, like, it's like a line that kind of just goes off on the yonder. Maybe that's why it's called. I don't know why we say that, but that's what a tangent is. A tangent is a line that touches just once. Hopefully the Giants win tonight, but kind of a heartbreaker last night. So anyway, there we go. That's just more terminology. Any questions on this? Okay. So let's keep moving. We shall keep moving. Use a diagram to find the given lengths. Okay, not that hard. I'm going to use maybe pink here so it stands out a little bit. Radius of circle A clearly is 3. Diameter will be double. Not that hard. Radius of circle B, clearly that's 2. Diameter of circle C this whole thing here, that's going to be 6. So, yeah, that's all. Not that hard. Any questions with that one? We're A-okay? All right, cool. Here, let's see, let's talk about this guy. In a plane, line segment tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint. Okay. Yeah, we talked about this already, right? So if the, I mean, I didn't say if, I said, the radius and the tangent line are perpendicular. Here they're saying that if you're tangent, then it's going to be perpendicular to the radius, same thing. So yeah, the radius and tangent are perpendicular. That's all it's saying. Kind of fancy words. So that's a right angle. That's a right angle. So you ask, is there a tangent line here? Well, actually, we need to figure it out. So what you're going to do, so this is where you have to extend yourself a little bit. What do we do with right triangles and sides? Pythagorean theorem. Of course, we did trig also, but Pythagorean theorem is how we compared the sides with each other, right? So a squared plus b squared equals c squared, right? A squared plus b squared equals c squared. Now, one thing that would help, this is the part that's not terribly obvious. This is 12 right here. Or this right here is 3. That's because you have a radius already provided for you, right? Now, this part's a little weird. The 37, I think you should be, I'm guessing the 37 is actually all of SP. And only this exterior part is 2. I'm guessing that's 2, but this whole thing here is 37. They should have just told us, hey, SP is 37. And they should have put a little thing here, like maybe put a different letter, like say B, and said BE is 2. So you may want to annotate your notes so it's not too confusing. We could say BE is 2, and we could say SP is 37. But we're just going to use Pythagorean theorem to see if both these, if we're forming right angles here, if both these are right triangles. So I'll do 12 squared and 35 squared. And compare to 37 squared. So I'll use my calculator. 12 squared is 144. 35 squared is 1225. 37 squared is 1369. 1225 plus 144 is 1369. So we do have a right angle here. These equal each other. So the answer is yes for the first one, for sure. And it's going to be yes for the other one also, because I have 3, 4, and that's 5. And I know that forms a right triangle because you get 9 plus 16, that's 25. That's one of the typical right triangles. So it's a yes also. So what you're doing is when you're being asked if a line that's touching the circle is forming a tangent, what you're trying to do is you're trying to prove it by using Pythagorean theorem. Because if you have right angles, it should satisfy it, right? Okay. So that's how you verify it. It's just you do Pythagorean theorem, and the 2 legs squared added up should equal the hypotenuse squared. All right, let's keep moving. We shall keep on moving. Here you have to find the radius, and you're told that it is a tangent. So in this case, you're going to say 80 squared plus r squared equals 50 plus r squared. Now that one's a little tricky because it's going to involve some more advanced algebra skills. We haven't talked about this algebra skill yet. It's called the FOIL process. You get 50 plus r times 50 plus r, which of course is 2500 plus 50r plus 50r plus r squared. So FOIL meaning you do first, outside, inside, last. I'm sure you guys saw this in Algebra 1. So you have that, and then the other side is going to be 6400. The r squares do cancel. You wind up getting 3900 equals 100r, because you got to move the 2500 to the other side, and r should be 39. So you're using Pythagorean theorem because you have the tangent, meaning it's going to be perpendicular to the radius, right? And so you're extending yourself by using some previous concepts. Okay, it's a right triangle, Pythagorean theorem. Let's plug it in. Then you use some algebra to work this out. And you get that. So I'm gonna have you guys try the second one on your own, see how it goes. You can do the exact same thing. I'll even do the setup for you and then have you guys try solving it, and someone can please share with me the answer. So you have r squared plus 24 squared equals r plus 18 squared. So just basically copy what you're emulating what I did in brown over here. Give you guys a couple minutes to figure that one out and tell me what you got. Hold on, make sure I do this right. Oh, 252. My apologies. Need something seem a little off there. There we go. Okay, should I got R equals 7? Okay. So hopefully that seems okay. There'll be some problems on the worksheet for homework that will be similar to this. And you guys are going to do another practice set on your own just in a little while. Let's keep moving. This is the last topic on, Anina, go ahead.
Can you go back? I'm sorry.
Here we go. Got it. No worries. Let me just readjust. Yeah, there we go.
Thank you.
Great. Okay, clear. Now let's move on. Tangent segments from a common external point are congruent. Okay, so yeah, if you had like something like this here, where that's a right angle, and this here, it's also a right angle, then these sides are going to be the same. And why shouldn't they? You know, and of course they should be, right? Because then you would draw this, and what's going to happen is that here's PRS, right? Here is PTS. Okay, well, PT and PR are both radii. They share PS, both right triangles, so they're congruent by hypotenuse-Lake theorem. So then, of course, these would be the same. So hopefully that makes sense that SR and ST would be the same. So these are going to equal each other right here, because you're told they're both tangent segments, and they're external. You know, they come from an external point that's outside. So 24 equals 3x. X is 8. Likewise here, x squared equals 9. X would be 3. Actually, technically, it could be -3 also, because -3 squared does get you 9. So yeah, so that's another type of problem you could see. So it's another concept. Excuse me. Okay, so let's keep the train moving here. So now you guys have a worksheet on 10.1 that I'd like you guys to work on. I'll put you guys in breakout rooms again. And if you have 1, 2, 3, 4, 5, 6, you're asked to label whether it's a radius, chord, diameter, secant, or tangent. The notes, we just did that. Give the length of the radius and diameter for number 7 and 8. Determine whether it's a tangent, just doing Pythagorean theorem. Solving for R for 11 and 12. And 13 and 14 solving for X. And you have all the odds. So let me put you guys in breakout rooms right now. And then we'll go over these. I say about 15 minutes. Then we'll do a break after that. And then we'll cover 10-2 after the break. Then we'll have lunch. Then we'll do 10-3. Then we're done with class. So that's kind of the plan for today. So let me go ahead and stop sharing. Pause. Okay, so you're asked to label these. BH is totally a tangent, it's a line. AV is a segment, that's a chord. AB is a line, that's now going to be a secant. AE is a line and it touches the circle at one point, that's going to be a tangent. CD is a segment, it goes through the center, that's a diameter. BD is a, sorry, that's the radius, my bad. It's going from the center to a point on the circle. And then BD is connecting 2 points, that's a diameter. My apologies for getting that mixed up. Okay, hopefully we're okay with that. 7 and 8 should be pretty straightforward. 7, they want the radius of circle C, that's of course 3. And the diameter is going to be 6, just double it. And for D, the radius is 2, and you double it, that's 4 for the diameter. This is yes. That's because 3 squared plus 4 squared equals 5 squared. So that will be a right angle, because you do get 9 plus 16 equals 25. 25 does equal 25, so A-OK there. Here, 9 squared plus 15 squared equals 18 squared. So check that out. You get 81 plus 225 equals 324. Actually, we're going to run into a problem. That'll be 306. And that does not equal 324. So apparently, AB does not touch the circle at one point. It actually will pass through another point. It's just hard to see it. So that's no. Because it doesn't satisfy the Pythagorean theorem. So, yeah, it probably is, my guess is, actually it's not obtuse. So it's probably doing something kind of like this. But it's kind of hard to tell the way it's drawn. Okay, that's number 10. For 11 and 12, you're going to set up this r squared plus 9 squared equals r plus 6 squared. And you do likewise over here, r squared plus 14 squared equals r plus 7 squared. And work those out. You should get, I think, I'm trying to think here. 12, 81 minus 36. 12. I think you get r equals 3.5 here. If I'm not mistaken, for number 11. Oh, 3.75, okay. Let me just, yeah, 3.75 if you were to work that out. Here, you have r squared plus 196 equals r squared plus 14r plus 49. 14r, 196 minus 49 is 147. R should be 10.5. Okay, for 12. And lastly, these have to equal each other, and these have to equal each other. This one should be pretty easy. You should get 4x equals 16. X is 4. That makes sense because you get 22. And 20 minus 6, you get 22 here as well for 13. For 14, set these equal to each other. Move everything over to one side. 4x was canceled, by the way. Actually, I put the 3 back to the other side. So technically it's plus or minus 1, but you can't put -1 because that makes that side negative. So we're going to say 1. And that will make that 3 here. If you put a 1 here, you get 3 again. So yeah, so X is 1 for that one. So that's number 14. Okay. So if you guys have questions about this, we can talk about after the break. Let's do a 15-minute break. Let's go to 10:45. Let's come back. We'll do 10.2. There's only one kind of worksheet on that stuff. And then we'll do a lunch break after that. And then after the lunch break, we'll do 10.3, and then we'll be done for today. And also we'll talk about the homework too, to give you guys a head start with that. All right, so I'm going to stop sharing. Let me pause. Okay, so I'm going to do all the evens right now. I'll have you guys try. Actually, I'll just do the whole thing. Not too bad. I'll do the whole thing with you guys because we have a homework on this anyway. So we're talking about arcs here. An arc is simply a portion of a circle. So if I were to draw, like, for example, if I were to shade this part right now, or highlight this part, that's an arc. That's all it is. An arc is just simply a portion of a circle. And it's or a portion of a circle's circumference. Maybe let me rephrase that. Because you could also look at you could also think of it like this too, like maybe this whole slice of pie, like a slice of pie or a pizza. If you want, you could think of it like that. That's called a sector. And I don't know if we're going to get into that until maybe in the next unit or later. I don't know when we talk about that. But we're just focused on the circumference part, just the outside. So it's like the crust. Think of it that way. The pizza or pie crust, not the whole slice. So we're interested in knowing the length of these arcs, or arc length. There's a formula you can use, but a lot of it's dealing with proportions. We'll get into that in just a little bit. But for now, we're going to talk about minor, major, and semicircles. So a minor arc, let me draw another circle here. And let me label this as A, and B. So I'll call this a minor arc. And I'll call this a major arc. Major obviously means bigger, minor means smaller, right? Or if you think about, like, if you're under 18, you're a minor because you're young. Or if you think of the military, like a major in the military is usually someone has a higher rank. Or in baseball, major leagues, that's the highest level you could play at. Minor leagues, obviously there's a lower, you have to work your way up to get to the majors. So hope that makes sense. Minor, smaller, major, bigger. And if you're connecting AB, AB could be connected as quickly as possible. So it's like, a short distance, and that's a long distance, right? So not that hard. Semicircle is exactly as the name's implied. It's half the circle. That's the biggest arc you could make. Well, it's not the biggest arc you can make, but it's the biggest minor arc, put it that way. The biggest minor arc you can make. And depending on how you label or how you do the letterings, typically sometimes we like, let me backtrack a little bit. The default let me do this again. If you see this symbol here, It's a little tricky, but let me look at the Ansky, how the Ansky does it. Yeah, okay. So the default, yeah, the old minors, okay. Will be minor to get as quickly as possible. So you're looking at BC, you're going to call that minor. Likewise with DC and AD and AE. We're going to call all those minor arcs. And then you're asked to find the measure of the arc. So the measure of the arc is purely dictated by the central angle. The central angle is the angle that is formed between the radius and using the center as a vertex. So for example, if this were like 80 degrees, and this arc here is also 80 degrees. Okay, it's also 80 degrees, that arc. So for BC, that's 70 degrees. For now here, because you have a diameter, you have 45 and 70, that's 115. That's 65 degrees. By the way, this is also 70 degrees right here. And that's 110 degrees. The reason why that's 70 is because that's vertical to that angle right there. That's labeled 70. So DC is going to be 65 degrees. AD is going to be 115. And AE is going to be 70. And again, we assume if you see two letters, you assume you're doing minor. So you want to get it as quickly as possible to that other point. So those are 1, 2, 3, 4. And to find the measure, you just simply look for the central angle. Now, let's look at 5, 6, 7. And let me readjust this. There we go. There we go. Now, ABC. So you want A to B to C. So now you know the order you have to go in. So that's going to be 180 degrees. That's a semicircle, by the way. That's 180 degrees. EAC, so it's all that. That's going to be 250 degrees, and that's a major arc. So minor is always less than 180. Semi is 180. Sure, I mentioned that earlier. And major is more than 180. And that's going to be 250 degrees. And then finally for ACD, all the way like that, that's going to be 135, 245 degrees. And that's going to be major. Okay, so hope that's pretty intuitive. So yeah, dealing with arcs. Arcs is a portion of a circle. It's kind of like the pizza pie crust, or the crust of the pizza or crust of the pie. Obviously, I use like my knowledge of vertical angles and linear pairs to get the other angles that you see inside that circle. Minor is less than 180. semi is 180, major is greater than 180. Yeah, and so you kind of, and then if you only see 2 letters, assume it's minor. If you see 3 letters, then just kind of see how long it is, and if it's more than 180, it's major. If it's exactly 180, it's semi. If it's less than 180, it's minor. Like I could have said AED, for example. If I did arc AED, you kind of do that little like portion of a circle right above this that indicates it's an arc. Arc AED, that measure would be 115 degrees. And that would be minor if it's less than 180. But ABD would be all this right here. If it did arc ABD. So sometimes it's better to have 3 letters so you're more clear about what you want. That would be 245. And that would be major. Okay, that'd be major. Eight. The answer is yes. And that's because even though you have a bigger circle, actually, let me take it back. It's more about the measure of the arcs. Let me backtrack a little bit. Well, hold on a sec. Yeah. Okay, so this is doing arc length. Okay, so the answer is no here and yes here. Okay, I'm trying to realize what they're trying to do here, but if you look at LP, arc LP is clearly going to be less than arc MN. The reason why is that if you look at this right here, you have 85 degrees for both arcs. But radius for LP is less than the radius for MN. So that's what's going on over there. And then here, these both have a radius of 8. The diameter is 16 for the second circle. So it's yes because same radius and central angle. Central angle is the same for LP and MN, but obviously the radius was different for both. Let's look at 10. 2 diameters of circle P are AB and CD. Okay. The measure of AD is 20. So let's draw. And I'll do that. And then C I'll put right over here, right across. Okay. Okie dokie. I got that. And I got that. And the measure of arc AD is 20 degrees, so that's 160 degrees. Right there. This would be also 160 degrees. That'll also be 20 degrees because you have the opposite of it, of arc AD. So when you want ACD, so I go all the way like that. That's 340 degrees. Okay. If you want arc AC, so the shortest possible distance, that is going to be 160 degrees. That's all. Questions on that one? Okay, we'll keep moving. We got 2 more problems. Again, any questions on 8, 9, or 10? So 8, the arc measures were the same, but the arc lengths were different because LP is shorter than MM because LP has a shorter radius. For 9, VW and XY are the same because it's the same radius and same central angle. And for 10, you just do a drawing, given the information you have there. Arc AD is 20 degrees, and AB is a diameter, and CD is also a diameter. And then you can kind of label the arcs like I did. Obviously, DB has got to be 160 because that forms a semicircle with a diameter. Semicircle is 180 degrees, right? Because a full circle is 360. And if you use vertical angles, BC is also 20 and AC is also 160. And you can solve for that question there. Okay, let's take a look at 11. Explain what is wrong with this statement. You cannot tell if those are same because the radii are not given. Well, here's the deal. That's a radius, right? Remember, a radius connects the center with a point on the circle. Well, clearly C is touching the point on its circle, and likewise a D. So the answer is yes. They are congruent. Since they share the same radius. That's the reason why. Because D is a point on circle C and C is a point on circle D, right? Again, D is a point on circle C, C is a point on circle D. And the answer key, that makes no sense. That's weird. Actually, I don't quite get that, but anyway, I know my answer is right. So, and then for 12, for those that like to play darts, definitely there's a lot of geometric probability that goes into it. You have 20 congruent sections because you have 20. I used to have a dartboard in my old house. I think I got rid of it. Unfortunately, it's just falling apart. But a lot of fun times playing darts. What is the measure of each arc in the circle? Well, you have 360 degrees for a full circle. Divide by 20, 18 degrees. So that's the measure of each arc. Is 18 degrees. So that's 18 degrees right here, and here, and so forth. And assuming that when you throw a dart that you land somewhere on the board, some people are pretty bad and totally miss the board. You can see like getting a bullseye or getting some of these like doubles or triples. A little hard to figure out. I'm not sure if we'll ever get into calculating that, but it's kind of a fun thing to do. Definitely makes you in awe of those who are very good at darts. Kind of reminds me of, I'm not sure if anyone watched the show Ted Lasso. There's one scene when he beats some guy in darts. It's kind of a pretty cool scene, but it's really hard to do, right? Like he had to, I think, hit like this right here and get a bullseye to win, and he did it. So kind of a cool show if you ever haven't watched it yet. Strongly recommend it. But just remind me of that show when I saw the dartboard. Okay, so I think we're okay with 10.2. So there's going to be a homework assignment on this. Let me show you the homework assignment right now. I think it's, yeah, arcs. And you can see here, like, name the arc given by the given angle. Angle FQE, that'd be arc FE. You can see it says here, arc FE, right? So I'm going to go over these with you guys before we finish our class today. Angle 1 is arc HI, right? Or name the central angle. So these are things I'll go with you guys before class gets out. This is part of the homework to give you guys more practice with arcs. So it's 11:10 right now. So the thing is, we do have to cover 10.3, which is on chords, and the little tricky stuff that we'll have to do. Then there'll be a worksheet that you'll do on it. And then I do want to go over some of the homework problems with you guys, just so you're not stuck. And then, of course, you have this video to watch. And then, then after that, we'll be done. So my thinking is about almost 11:10. Let's do a 40-minute lunch break. Let's come back at 11:50. So kind of one of our earlier lunch breaks. So let's come back at 11:50. So 40-minute lunch break. When we come back, do 10.3 and then the worksheet that goes with 10.3. Should probably take about 30-40 minutes to do both of those. And then I'll briefly talk about the homework. So we should be done by about 12:40, 12:45 today. So we'll finish a little early like we usually do. Anyway, let's do a 40-minute lunch break and I will see you guys at 11:50. Okay. Okay, so let's do another warm up again. So factor the following. So x squared plus 8x plus 15. Hopefully you guys remember your factoring skills. What you want to do is you want to find two numbers. That multiply to 15 and add to 8. That's all. So if you think about 3 and 5 are two numbers that multiply to 15, add to 8. So you can factor it like this. And if you were to FOIL, you should get back to the original expression. X times x is x squared, x times 5 is 5x, x times 3 is 3x, and of course 3 times 5 is 15. And then combine like terms in the middle, you get x squared plus 8x plus 15. There you go. Little IQ test, that's just more like look for patterns and numbers. Hopefully you recognize that's 1 squared. And then, 1 cubed, 2 cubed, 3 cubed. You got 5 and 6 cubed over here. So this number would probably be 64, which is 4 cubed. So that's just a warm up. Now let's talk about our concepts. So we're talking about properties of chords. So if you have two chords that are congruent, or actually two arcs that are congruent. So AB, or let me highlight it. AB is same as CD. Then the arcs that form them are also going to be the same. So if arc AB is congruent to arc CD, then segment AB is congruent to segment CD. So I hope that seems intuitive. So you have two circles here. They're both the same circle, meaning they have the same radius. So you see this radius and this radius, those are identical. You do different colors so it stands out a little better. Also, you're told that FG and JK are the same. Those are two chords. So that means that this would also be 80 degrees right here. And there we go. That's it. That's the answer. That's all they want. They give you arc JK. So there, you have the same circle. So in the same circle or congruent circles, obviously this case is congruent circles. This case, that was the same circle. If both chords are the same, then the arcs they form are the same, or if both arcs are the same, then the chords that form them are also the same. So that's the concept here. So let's try some more here. So arc AB, remember the default is you go for the minor arc. So let me get a highlighter here. That is 110 degrees. And clearly AB and BC are the same because they both equal 9, right? So those are congruent arcs. So let me do a different color, I guess. But those two arcs are the same. So arc BC is also 110 degrees. So that's 110, and that's 110. So that's at the 220. So all that right there is gonna be 140. Because remember, you need 360 degrees for a full circle. So I hope that seems intuitive. Okay. What if we had different values for these arcs? We'll say arc AC. Let me get a highlighter out again. Is 150 degrees, right? Arc AC is 150 degrees. Well, these are still going to be the same. That right there, and that right there. Those are still going to be the same. And what you'll have to do is you have to do 360 minus 150 divided by 2. So each of these is going to be 105 degrees, which makes sense because 105 plus 105 is 210, adds 150, you get 360. So arc AB is 105 degrees. Then ABC is 210. If you go A to B to C, if you go in that order, that'd be 210 degrees. Questions on that? Okay. Let's keep moving. Couple more, oh, actually 3 more theorems and some practice problems to apply those theorems. So again, a lot of this is applied math. If one chord is a perpendicular bisector of another chord, meaning it cuts it in half and is perpendicular, then the first chord is diameter. So yeah, so SQ has to be a diameter, or QS. If you think about it, like what if you had something like this here? Here, I'll draw a chord. We use the same letters, T and R. And so I have another chord, but it's not a diameter, right? Clearly it's not a diameter because the center would be like over here somewhere. That's not cutting that red chord in half, right? It could be perpendicular, but it's not cutting it in half. Or let's say it does cut in half, but it's not perpendicular. So maybe say we do have something like this here. So it cuts the red chord in half, but not perpendicular. That green chord's probably not going to be a diameter either, because it could have looked kind of like this too. So you have to be both perpendicular and cut in half. Then SQ would be the diameter. Another one here, if the diameter of a circle is perpendicular to a chord, then the diameter bisects a chord and its arc. Yep, so the arc here, we'll shade, here's FD. So FD gets cut in half, so therefore GF and GD are the same. GF and GD are the same. So yeah, if you have EG, that's your diameter, and it's perpendicular to FD or DF, then it's going to obviously cut DF in half, right? Because it's a bisector. Well, we know that from earlier on. If it's perpendicular, it's going to be a bisector as well. And it's also going to cut the arc that the chord makes in half as well. And then lastly, this should seem intuitive as well. If you have two radii, or not radii, sorry, you have two chords, CD and AB. If it so happens that they're of equal distance from the center, so see you have FE and GE, or EF and EG, same thing. If they're of equal distance, both chords are equal distance, and the chords themselves will also be the same. Or if you have two chords that are the same, then they'll both be of equal distance to the center. And so the if and only if means you can go both ways. So the inverse is also true. Sorry, the converse is also true. Okay. So let's look at some problems here, and then we'll have you guys do some practice. So given the perpendicular bisector, find the requested length or arc. Okay. So you want arc AC. Sorry, you want segment AC. Well, this is also going to be 7. So AC is going to be 14. Because remember, the diameter is going to cut in half. Also remember that these arcs are the same. When you have a diameter going through the middle of a chord, as you see how BD goes to the middle of CE. So arc CD, well, first of all, let's set them equal to each other and solve for X. So you get 10X, X equals 8. So that means that this is 72 degrees. Because that's just 9 times 8, right? And CE is double CD. 72 plus 72, which is 144. And this one here, given the congruent chords, find the requested length or variable. So CU is 2x, CV is 5x minus 9. Those are going to be the same because they're both of equal distance. Well, the chords are congruent, so you assume that they're of equal distance to the center. So 2x equals 5x minus 9. 9 equals 3x, x is 3. So then CU would be 2 times 3, which of course is 6. Then here, 3x plus 2 and 22. Well, 3x plus 2 is half of AD. So I'm going to multiply that by 2 and set equal to 22. Remember, it's hard to see, but BC is a chord, and it's going to be the same as AD. So BC is going to be congruent to AD. Because they're both of equal distance. So 2 times 3x plus 2 equals 22. So 6x plus 4 equals 22. 6x equals 18. X is 3. And that's all you're being asked to solve for. So hopefully that seems intuitive, not too bad. Any questions? Okay, I'll give you guys a chance to copy that. Then we're going to do a worksheet so you can practice these skills. We'll do that for about 15 minutes or so. And then we'll talk about the homework after that. But any questions? Okay. So we'll clear this. And actually, I'll go back to sharing my screen again. So now you guys are going to work on this packet, 10.3 worksheet. It's in the packet handout to you guys. Also, you can find in Schoology under. And sorry that PowerSchool isn't sunk yet. I don't know what's the hold up. I can also email you guys your grades too. Yeah, I could do it later today. But yeah, if you go to chapter 10, theorems and definition. No, it's gonna be right here. And so let's do 1 through 7 only. I don't know. I think we could do all of them. Yeah, I don't see why we can't do them all. Sean, you have a question? Go ahead.
My grade just loaded, if that helps you.
Oh, it did. Oh, thanks. Okay, I guess maybe it just takes a while. Actually, let me see. PowerSchool. You can try to do it periodically. So says, oh, that's weird. Okay, anyway, well, that's good. At least you can see it. So, okay. Well, great. So, yeah, so let's go and work on this worksheet. Put you guys in breakout rooms again and call me over if you have questions. Hold on a sec. It's right here. Yeah, so I'm just gonna have you guys do 1 through 9. Take about maybe we'll come back at around 12:24. So I'll do another 15-minute breakout session. Work through these. I'll go over them with you guys. Then I'll talk about the homework, and we should do that. We should be done around 12:45 today. So okay, so I'm gonna go ahead and stop sharing my screen.